And I'm recording it in case you zone out, all right? So number one, nth derivative is given by this mess for n bigger than 1. What is the coefficient for the term containing the x to the 5th in the Maclaurin series of G? You don't need to do the entire thing because we only need that one term, okay? So if we want it to be x to the 5th, what are we going to plug in there? Right, yeah, it'll be the 5th derivative. This is 0, right? Because it said Maclaurin. Over 5 factorial x to the 5th. That's going to equal, and then we want to plug in 5 on this side. So 5 plus 1 would be 6. Negative 1 to the 6th would just be 1. So actually you get to sort of ignore that part. So it'll be 5 factorial over 6. And you don't really need the x to the 5th. So I'm not even really sure why I wrote that. This right here is actually just the pattern of this. I didn't need to write this. I don't know why I did. Because I just tend to write all of it. And then over here, we plugged in 5. Yeah, so the 5 factorials are going to actually cancel if you divide 5 factorial over. And so you just end up with 1/6 is your answer. If you feel like that's it, yeah, it's because we were only looking for that one term. We weren't doing the whole thing, which honestly is almost more confusing because it's like you're just doing that one term at a time. Honestly, I think questions 2 and 3 are easier because you end up writing the whole thing out. That's what I like to do. I like the pattern, like writing the whole thing out. What are the first 4 non-zero terms of the Taylor series? Okay, this one's not centered at 0, it's centered at 2 of f. I'm going to write the whole thing out. All right, so we want f of 2 over nothing factorial x minus 2 to the nothing plus the first derivative at 2 over 1 factorial x minus 2 to the first plus second derivative at 2 over 2 factorial x minus 2 squared. Wait, how much further do I have to go? 2 through 4. Okay, one more. Plus the third derivative at 2 over 3 factorial x minus 2 to the third. I would write it. It is more about staying organized than anything else. Okay. Now they handed us these numbers, which is fantastic. F of 2, they said, is 3. 0 factorial is 1, and anything to the 0 power is 1. So this entire first term is literally just 3. Plus, all right, let's see what the next one is. First derivative is -1 and then over 1. So actually this will be minus x minus 2. Plus, all right, what'd they say the second derivative was? 1/3, and then it's over 2. So that'll be 1/6 x minus 2 squared. And then the last one, the third derivative is 3/4. I'm just going to write this off to the side. It's 3/4 over 3 factorial is 6. So that would be 3/24. So 1/8 x minus 2 cubed. I do want you to simplify the fractions because a lot of times these do end up being multiple choice questions and you're going to have to simplify them. Okay. Does anybody agree with me? Like, I think that was easier than the first one, if that makes sense. I know it was more work, but like it's a process. If you just have to pull out like one term from the list, I find that harder. All right, find the third degree Taylor polynomial. Unfortunately, you're not handed these numbers, so we're going to have to find the derivatives. Okay, so what is our first derivative? Let's just go ahead and do that. Good. This is x to the -1. So if you bring that negative down, it'll be -1 over x squared. Second derivative will be, now if you think of this as -1 x to the -2, the negatives will cancel. 2 over x cubed. And then third derivative, good. Why do we get to stop there? Third degree Taylor polynomial. Okay, I write this out every time. I guess if you don't want to, fine, it's just my suggestion. All right, what are we centered? 3. F of 3 over nothing factorial x minus 3 to the nothing. And so I stopped when I got to the third power. All right, so f of 3, that's the original function. What do you get for that? 1/3, and then all the rest, that's 1, so that's all gone. All right, first derivative at 3, that's going to be negative 1/9. So negative 1/9 times x minus 3. Second derivative at 3, that would be 2/27. But then we're dividing by 2, so the 2's would cancel. So 1/27. What's that? Yeah, is this one gonna cancel too? Oh yeah, because the 3 factorial is 6. Okay, cool. So that's gonna be negative 1/81st, 3 to the 4th, 3 squared squared, negative 1/81st x minus 3 cubed. It's not too bad. You just have to write it out. I say write that every time. All right, this is the one like what we did today. I would write all the information out off to the side. What is n? Oh, we don't know. Whoops. Question mark. All right, c is 0 and x is 1.3. They kind of tucked that away in there. All right, so we need, well, actually it's e to the x, right? So it doesn't even matter what degree we need because it's going to be e to the x. You would do e to the 0 and e to the 1.3 and take the bigger one. Which one's going to be bigger? Yeah, good. It's the e to the 1.3. That's the first part. Next is x minus c to the n plus 1 over n plus 1 factorial. We want that smaller than 0.001. And then you just have to go, what if it's 5? What if it's 6? What if it's 7? What if it's 8? Until you get something that's smaller than 0.001. What did you guys get when you tried? 7? Me too. Perfect. Maybe write a note, used calculator, because when you go to study, if you look at your quiz review, you're going to be like, how on earth did I get that? Because it looks like we didn't do anything. All right, this last one's a lot of like work, but I don't find these too bad. If you remember the ratio test from last unit, it's really not too bad. It is a little bit of writing though, that's why you have all this space. All right, so to get the radius of convergence, you're going to do the ratio test. So we're going to plug in n plus 1. And then that goes over the series itself. Gosh, that looks awful. Basically just writing the same thing twice though, just one of them with an n plus 1. So then we're going to reciprocate. And again, try to line everything up so that it all matches. And I'm going to have to come down to the next line after that because I'm running out of space. But, you know, hopefully a lot of stuff's going to cancel. So like these 4's cancel, that's gone. So we're still going to have an x minus 5. Where would it be? On the top? You can't do anything with the n squared and the n plus 1 squared, so you're going to have to just leave those. And then we're still going to have a -4. Where is that going to be? Which actually, I'm going to write it as just 4 because we're doing an absolute value anyway. So it's not going to matter that it's negative. All right, now we're going to evaluate the limit as n goes to infinity. This is n squared. This is n squared. So when it's the same, you use the coefficients, which is the x minus 5 over 4. And ratio test says that that has to be smaller than 1. You would multiply the 4 over, and so your radius of convergence is 4. So you can get 4 units away from the center. And we said, where's the center? Center is at 5. So 4 units away will give you 9 and 1. So then you have to test those endpoints to see if you include them or not. So let's let x equal 1. You're going to plug 1 in for x back in this horrible original problem, right? So we're going to plug 1 in for x there. That'll give you 4 times 1 minus 5 will be -4 to the n over n squared. Ooh, -4 to the n. That's actually not going to be too bad because why? Yeah, those cancel. And then what kind of series is that? P-series. Converge or diverge? Converges. Geometric is the other way around. It has to be smaller than 1. So we're going to include the 1. And then we're going to look at the 9. So we're going to plug 9 back into that original problem. So 9 minus 5 would be 4. So 4 to the n over n squared. Now, see how that's -4 to the n there? I'm going to write it as 4 to the n times -1 to the n so that I can get those 4 to the n's to cancel. The fact that it's a -4 is just going to make it alternate. So this is an alternating series. So we're going to do alternating series test. So what's the first part of alternating series test? There's 2 parts. Limit needs to go to 0, which it does. And then what else? Like, yeah, the actual one. And that's true because the bigger denominator means the smaller fraction. So this also converges by alternating series test. And so you guys told me I could abbreviate this. Don't do that on the AP exam, but interval of convergence, we're going to include both of them. So bracket 1 to 9.